Hello everyone, my name is Łukasz Mirosław. I'm a global black belt specialist for HPC and AI at Microsoft. And today with me we have Théophile Allard, the CTO of Newer Concept and also one of the co-founders. So before we start, we would like to just phrase that AI engineering is the reality today, and we betting very strongly on that technology, and therefore we have with us the leading partner in that space. So Theo, would you like maybe to tell us more about what is your role in the company, what is your accountability?
Yeah, sure. Hi, Łukasz. So at Neural Concept, I'm responsible for product development. So I lead the software engineering team, which builds our software platform that our customers use to train 3D AI models for product development.
Newer Concept is considered today as one of most innovative startups in Switzerland, and also the new player in AI in engineering space. You were listed as a finalist for Swiss as one of the 3 finalists for Swiss Economic Award. Could you elaborate on that about your positioning in terms of innovation and the startup ecosystem?
Yeah, so we started 6 years ago as a spin-off from EPFL. Originally, we're a team of deep learning experts working on computer vision and video applications, and then we realized that these 3D deep learning technologies could be extended to other realms than computer vision. So we had the idea to apply that to understand 3D shapes and predict the physics. And while doing this, we were really pioneers in the application of deep learning for engineering. And based on that, we built a whole software platform. And over the last 6 years, we've been working with tens of different industrial customers, a lot of them in the automotive industry, but also aerospace, electronics, and today, more than 50% of the car OEMs in Germany and Japan, for example, use our technology to virtualize their product development.
This is fascinating that you were able to bring this technology to the largest OEMs, and not only here in Europe, but also in Asia and US. Is this, let's say, a part of your mission to move towards automotive, or you also have other sectors that you're betting on?
So the technology is very modular and quite agnostic to the physics. So actually it can be applied to all the industries, and it can be also applied beyond aerodynamics in the automotive. It can be also applied to electromagnetics, for example, structural mechanics. So we have very diverse applications. Let's say that today a lot of our business is in automotive, but we're expanding to other markets. We have some historical customers like Airbus, Safran in the aerospace sector. We have a lot of new customers also in consumer electronics.
Mm-hmm. And that's exactly the value we see while collaborating with you. Our companies already initiated a number of projects together. How do you see the value of partnership with Microsoft?
So working with Microsoft allows us to benefit from very scalable and reliable cloud infrastructure. So leveraging Azure allows us to spin off AI workloads at an unprecedented scale. I can think, for example, one of our customers in renewables running over a couple of days very regularly. So for every new project, they run millions of evaluations of different turbine blades, for example. And this is only possible thanks to the elastic high-performance compute capabilities of Azure.
And the history of Newer Concept is very dynamic. If you look at the history, you probably have reached certain milestones. You started just with a few founders, and right now you are employing I don't know how many engineers, but maybe you could elaborate more about those milestones and key achievements.
Yeah, definitely. So today, to precise, we're around 65 people in total. We started 6 years ago, so as I was mentioning, in the computer vision lab at EPFL. And there we very quickly started working with some industrial customers. So in the early days, Airbus was one of our first customers. I remember, I think it was in 2019, we hosted a joint workshop with Airbus at, I think it was ICML, so one of the top machine learning conferences, showing how our technology could predict the location of shock waves on the plane wings. In the early days also we had the opportunity to optimize an aerodynamic bike which broke a couple speed records and is currently recognized as the most aerodynamic bike out there. It doesn't look like your standard bike, more like a human-powered rocket on wheels. But yeah, so these were the early days, and then based on these successes, we were able to build our customer base around the industry, and around the technology. Very quickly, the focus shifted towards building a modular platform that would empower all engineers to leverage the power of AI and deploy it, integrate it into their product development workflows.
And this part is very interesting in terms of how you started, because you started with your model that was very powerful, able to capture different types of physics by training from examples. But right now you shifted your let's say attention to the platform. And could you maybe explain more how the platform works and in terms of the technologies that you're leveraging to really empower engineers?
So the platform is here because, so actually for the anecdote, in the early days, we actually built in the first years a fully integrated platform which had a nice graphical user interface, and you could choose a model, run predictions, and start an interactive design session, for example. So that was a black box system, but actually, it was not flexible enough for the needs of the bigger industrial players. And what we realize is these AI models are great technology bricks, but when you want to put them in production, you need to be able to leverage the experience of each industry player, all the data they have, the knowledge of their internal experts, and then create a tailored tool chain that you will integrate. And therefore you need an interactive development environment. And that's what the NeuraConcept software is today. It's an interactive development environment where you can leverage physics predictive models, you can leverage 3D generative models, and combine them together to build tailored workflows for your application. And this requires a lower level kind of user experience. But today is a very exciting time with the advent of large language models, for which the codes like interfaces are the perfect medium to express the power of LLMs and help the engineers actually build these tailored solutions way faster than they could have done before. So let's say the platform is a unique environment to combine these three technology pillars: generative models, physics predictive models, and make development of tailored solutions way faster with LLMs.
So this is a great point, that you are actually bringing together those elements inside the platform, but also in terms of the real benefit to the engineers. How do you see the key, let's say, KPIs that you are able to address when proposing such a technology to the engineering teams?
So the key, there are two categories of KPIs. So the first thing we do is we really accelerate innovation. We reduce development time, so by 25 to 50% depending on the applications. We accelerate development time because the AI models, compared to traditional simulation and design software, are way faster to execute, but they also offer simpler interfaces in terms of, let's say, systems integration. Once they are trained, they can be be plugged into different systems in a very modular fashion. So this streamlines a lot the processes. And then the second type of KPIs, the two are quite related, but the second one is performance. So as you accelerate your process, and also as you can explore more different design variants, you end up with a product that is more performant than before. So for example, regarding this renewables energy customer I was mentioning before, optimizing the turbine with one extra point of performance and of operational efficiency for the turbine leads to massive economies in terms of monetary value. So if you can avoid certain penalties due to a mismatch in performance, it's millions of dollars you will save on your project.
This is fully let's say clear that it's about saving the engineering hours. It's about saving the, let's say, compute hours, and also increasing the efficiency. But this is for the build phase. But what about operation phase? Are you able to see some examples of applications where you can actually combine your responsive AI that gives responses very quickly with some additional capabilities such as reinforcement learning to create a simulation-based digital twin?
Yeah, so definitely these models are perfect to power simulation-based digital twins. They can be deployed as APIs and then be integrated inside design tools, but also inside more operational digital twins. So we have a great example. We're working with a team called SPAT, who's on a mission to break the wind-powered speed record. And as we speak, they're actually using a fully virtual replica of their boat that will break the record to adjust some settings of the boat, in particular the foil they use to make sure the boat is ready to break the record. And the digital twin is powered by neural concept physics predictive models, so that the driver, so the pilot of the boat can train to control the boat before they start doing the test runs.
Yeah, this is a great example. How did it happen that you started to collaborate with us in the sport industry, so to say?
Yeah, we have a few examples of projects with the sports industry because it's an industry where it's all about performance. You know, so naturally they're interested about the type of technology we can offer. SPAT in particular is a project that also started at EPFL. So we're actually quite friends with the founding team. And it's been an exciting journey so far, working with them over the past few years as they completely reinvented how sailing could be done. Actually, when we speak about the foil they use on the boat, for example, it's not a standard foil like you see on America's Cup, because when they go 130 kilometers per hour. So it's almost twice as fast as America's Cup boats. So when you go at this speed, the physics behave completely differently, and you need to pay attention to a phenomenon called cavitation, which would risk to completely break the foil. So they needed to deep dive into these challenging physical problems and would be really innovative in terms of designs.
So this is one of the projects that you can be really proud of. Can you think about any other projects that are also bringing a lot of impact?
Yeah, definitely. So we mentioned our strong presence on the automotive sector, for example. Currently, we work with more than half of the OEMs in Germany and in Japan. So, for example, Subaru is using our models to optimize the external shape of their car for better aerodynamics. And today, making cars more aerodynamic is really essential. So for thermal cars, that allows to reduce the carbon footprint of the cars. For electric vehicles, it allows to increase the battery range of the car. So these two are essential challenges the OEMs are currently fighting with. And we're proud to say that our technology is helping them dramatically address these challenges.
When you started, you were one of the pioneers, but right now I think there are more and more, smaller, bigger startups trying to replicate what you've done, maybe with some other models. So how do you see yourself as a key differentiator?
So first, it's quite exciting to see the market evolving so fast these days, and there's so much happening in the ML community. I think it's really an exciting time to be working in that field. I think as pioneers we have the key advantage that our technology has been battle tested for the past couple years with tens, like almost 100 of different big industrial leaders in their respective fields. So that allowed us to iterate many times on the underlying engine and make it robust and reliable. Then the other key advantage we have is this platform positioning. So I believe we have the most advanced commercial 3D deep learning engine available for engineering today, but we also have this whole platform around, which allows cutting edge process automation, so to connect with all the different CAE and CAD tools on the market. And we also allow our customers to plug in other technologies. So if they have some custom models they have developed in-house, they can bring them into the platform, they can connect with other vendors' tools. And we believe this is essential to build solid production applications and truly transform their processes.
And I'm just thinking out loud, since your AI model is able to represent one component of the multi-component assembly, I can imagine that in the future you could have multiple AI models representing different parts of the big system. How do you see your technology emerging? How do you see your technology evolving into, let's say, multi-objective, multi-component AI training? Let's say trying to optimize for certain objectives. So do you see this as a evolution, or you have what is your vision for the future applications?
So this is already something we do today. Oh. So again, going back to this speed record, like wind-powered speed record example, the SPAT team is optimizing for fluid and structure at the same time on the foil. And these are two different models predicting two different kind of objectives, which are related, which are coupled. So the two models are talking together in real time, so that the fluid model takes into account the deformation that comes from the structure models. And in a similar fashion, we can do the same to have different models predicting the behavior of different components and talking to each other in real time to simulate a bigger system. And this is definitely something we see as an evolution, that more and more our technology allows to emulate bigger systems. And our vision is really to virtualize completely the development of large systems as part of the product development process.
So I'm pleased to hear that you are doing this today, multi-component, where you have multiple AI models talking to each other, optimizing for a certain objective. This is amazing. But also, if in terms of implementing newer concept platform, you also probably face multiple challenges. So how are you facing those challenges? How are you addressing them?
Yeah. So one key challenge we see on the way to bringing this technology deep into engineering organizations is the management of IT environments and the transformation of IT environments. That's also one of the big advantages of working with Microsoft. The IT environments in engineering today are very fragmented. So depending on the industry, depending on the companies, we see very different patterns. However, if one really wants to bring this technology at scale, the ultimate environment needs to be scalable, elastic, and to have cutting edge hardware, because we know the the power of AI is also coupled with the power of the underlying hardware. And therefore, we're working very closely with our customers. We have a great platform team working with our customers, accompanying them through this transformation to create and update new high-performance computing environments, couple it with the power of the cloud, and make sure the infrastructure is ready to welcome these new technologies.
Mm-hmm. Yes, and but this is one challenge. I also think that maybe we can talk a little bit about the data. As you know, in order for your model to be performant, you need historical simulations. So is this a challenge for some customers, or they are already having those data available?
Yeah, it's similar actually. It highly depends on the customer, on the profiles of the customers, on the industries. We see some customers which are very mature in terms of data organization, data saving. I mentioned working with Formula One teams. Formula One teams have amazing data sets for external aerodynamics with thousands, if not tens of thousands of different variants of the cars that they can store in their systems. Some other companies have more fragmented processes and struggle to store a unified view with well-structured information for the models to learn from. So we're also working with our customers and helping them structure their approach towards the saving and organization of the data. Actually, organization and structuring of data sets is one key feature of our platform as well. But another aspect is, thanks to the integration of the platform with design and simulation tools, we can also generate new data to train the model. So we leverage the existing data as much as we can, depending on how much we could find. And then based on this, the system can determine how much data to generate extra, how to enrich this data so that we have a data set that is fit to train appropriate predictive models.
So I see it as a integration of traditional HPC with your AI technology, with the ability to train, retrain on demand, right?
Yes.
Based on the signals from the models. And then you mentioned that there is a certain a feedback that your technology is providing. So depending on the feedback, how the model performs, you can actually automatically initiate additional training, additional simulations, traditional simulations to retrain your model. Can you elaborate more about that?
Yeah, definitely. So that's what we call active learning, which is a key feature of the platform. It's based on some uncertainty quantification coming from the model. So the model can give a confidence indication whether a prediction can be trusted or not. And then as we explore new designs, as we optimize a design, we may have a confidence indicator that is decreasing. In that case, the platform is able to call external softwares, CAD software, CAE software, or even in-house tool chains that have been developed, so that it's able to generate new data on the fly to update the model and continue optimizing.
Yeah, and in the cloud, this can be realized much more efficiently. Also, I think that the security could be also a challenge. So do you see a cloud with confidential computing as a way to address those challenges?
Yeah, so I think security, so having the appropriate access control and security settings on the cloud environment are essential, and we're working with Microsoft on confidential computing topics. I'm happy also to share that over the past few months we've been both ISO 27001 certified and TISAX certified to bring our customers confidence that when they work with us on our SaaS environment, their data is safe and treated in the best way possible, so that it's used to create impact on their systems and treated completely confidentially by our systems.
such an innovative company, by the way, these stories are really great, and thank you for sharing those. How do you see your also long-term goals and also the ambition as a newer concept, being an innovative startup from Switzerland?
So on the long term, let's say our goal is really to transform, to help the industry transform itself, to bring more virtualization into product development processes. And the goal there is really to solve the challenges our society is facing. So we know we need to make our industrial systems, our products, more energy efficient, for example. If we're able to multiply by 2, by 5, by 10 the speed of technology innovation thanks to more virtualized product development, we can reach faster our objectives in terms of energy efficiency improvement, for example. So I really see our technology continuing to percolate through the industry and helping them accelerate innovation.
And Theo, maybe you can also tell us a little bit more about your roadmap and about your plans in terms of the next versions of your platform.
Yeah. So in terms of short-term next steps, stay tuned for the release of Neural Concept version 4.3, which is coming in the next few weeks, with a few highlights, such as an improvement around the data organization system. So we can include more metadata in the way we organize data sets and create more tailored workflows, taking into account the specificities of each product development workflow. Another highlight is the improvement of our NC Assistant, so the LLM-based copilot in the platform, which will now automatically guide the users through error resolution. When they're developing a workflow, if they get an error, the assistant will be able to correct it for them automatically. And then a final highlight is the release of a new simulation interface, so a new integration with our partner Rescale, so that we can use the Rescale REST API to trigger on-demand simulations with elastic HPC infrastructure directly from the NC platform to offer truly end-to-end workflow, in particular for thermal management application and external aerodynamics applications.
Mm-hmm. Yeah, so that's great that you also have this integration with Rescale, who is also our partner, because then if it's powered by cloud infrastructure, then I think the IT effort on the customer side is much lower.
Yeah, this will become the new fastest way to get an end-to-end workflow running with zero IT effort.
Mm-hmm. Perfect. So thanks a lot, Theo. That was a very helpful conversation, and I'm really appreciating that you have visited us, and also looking forward to the fruitful collaboration in future.
Thank you, Lukasz.
Thank you very much. Thank you, everyone.